Okay, welcome back to the video. We're going to start with problem number 2. The problem number 2 is about elevations, and it says the world's tallest mountain, if measured from base to peak, meaning from bottom to the top, is Mauna Kea in Hawaii. The base has an elevation of 19,680 feet below sea level. The top, the peak, has an elevation of 13,796 feet above sea level. How tall is Mauna Kea? Now, the one question you might be asking is, how is this the tallest mountain? Because most of us think that the tallest mountain in the world is Mount Everest, right? Now, take a look at the picture. So, Mount Everest, is it the world's highest mountain? And if you could look at the picture here, the Mount Everest from the base, which is the ground, to the top is 5,200 meters. Now, if you look at Mount Kea, the base is underwater. You see the sea level here? The base is underwater, and so to the top is 10,200 meters. So the base is underwater, so if you actually count from the base to the top, Mount Kea is the tallest in the world, and it's in Hawaii. Okay, so we learned something new, but let's learn some more. So with our 5-step process, the first thing we need is to identify the integers. Now, it says the elevation is 19,680 feet below sea level. We know what it means when it's below sea level. That means our integer is going to be negative. So it'll be negative 19,680. Then the second integer, if we read the word problem, it says it's 13,796 feet above sea level. So above sea level, that would mean that this is positive, and yes, the integer is positive 13,796. And we want to know how tall the Mountain Kea is. So again, our two integers we have is negative 19,680 because of the word below sea level, and then positive 13,796 because that's above sea level. So if you think about a mountain, which I will start drawing in here, I'm going to draw the mountain tall like this, okay? The base and the top. And we know that because I've shown you the picture, a part of it is underwater and the part of it is above water. So I'm going to have the water right here. And as we know that if it's water, it means that it's at sea level here. And at sea level, that probably means that this is 0 feet. And you can think of it in terms of a vertical number line, and 0 will be right here. Since we know that the bottom is negative 19,680 feet, we're going to label that here. And the peak, the top, is 13,796 feet. So, very similar to the thermometer, which you did in the first video lesson here. This problem, we're looking from distance from the top to the base. From the distance from highest elevation to the lowest elevation. And that is going to be a subtraction. We're trying to find the difference between the high elevation and the low elevation. So it's very similar to the first problem we did with the thermometer. It's going to be difference between the two elevations. And again, difference means subtraction. So our equation for this is the top number, the high number, which is 13,796, subtracted by the low number, negative 19,680. So we're going to do the subtraction problem using keep, change method again. So we'll have 13,796, and then change subtraction to addition, and we're going to take the opposite of the second integer. This is negative, so it's going to be positive. Positive 19,680. And we're going to have to add this. I know it's a large number, so you're probably going to have to set it up vertically. So we're going to do that. Let's show our work. If you add them together, 6 plus 0 is 6. 9 plus 8 is 17, so 1 goes up carried over. 1 plus 7 is 8. 8 plus 6 is 14. So 4 here, 1 on the top. 1 plus 3 is 4. 4 plus 9 is 13. So carry 1 over again. 1 plus 1 plus 1 will give us 3. So our Mount Kea is 33,476 feet tall. And again, the drawing is really important here. It tells us that the top and the low, and we figured out that we're looking for the difference, which is subtraction. And just like the picture, the first problem again, the distance from the top to sea level, which is 0 feet, is again 13,796 units. And then from 0 to negative 19,680 is 19,680, just like absolute value. And together would give us our answer. The picture, again, is really, really helpful. Okay, so problem number 3. Suppose that a baseball drops at a rate of 4 feet per second. After a baseball player hits a home run, it takes about 5 seconds for the baseball to come down from the air. What is the distance traveled by the ball during this time? Okay, and if you need to, I'm going to give you time to pause the video and reread the problem on your own. Okay? Okay, otherwise, let's take a look at it and identify the integers. So we're looking at a baseball falling at a rate of 4 feet per second. And we're looking at 5 seconds. So for our first integer, the ball is dropping down and its rate of 4 feet per second. Dropping, you would assume, is a keyword for negative, right? So our first integer would be negative 4 feet per second. And then we have the time, and we know that it's going to be 5 seconds. It takes 5 seconds for the ball to fall, so that will be our positive 5, the second integer. So for the first integer, the ball is dropping, that's negative, and then the second integer, we know that the ball is traveling for 5 seconds. So the ball is going down 4 feet every second for 5 seconds. So we're going to draw the ball falling down. I'm going to draw a baseball. Baseball will probably look like this. It's going to be falling. If it falls for 1 second, that's dropping 4 feet. And then it's going to drop again. That's another 4 feet. So far it's 2 seconds, we're falling down for 5 seconds. So another second passed, and we dropped another 4 feet. And then we had dropped another second, that's 4 seconds, we dropped another 4 feet. And then we're going to go one more, because we want to know that we know that the ball is traveling for 5 seconds. And that's another 4 feet. So 1 second, after 2 seconds, another 4 feet, after 3 seconds, another 4 feet, another 4 seconds, another 4 feet, and after 5 seconds, it dropped another 4 feet. And again, we're doing this for 5 seconds. So here we're going to be adding up all those seconds, which is 5, and then we're looking at the distance traveled by the ball. So 4 feet, negative 4 feet plus negative 4 plus negative 4 feet plus negative 4 feet plus negative 4. We're doing that for 5 because it's 5 seconds. And look, this is a repeated addition. And guess what? We learned that repeated addition means to multiply. So our operation is going to be multiplications. And if we multiply, we're going to multiply the first integer multiplied by the second integer. And we see we have 5 groups of negative 4. So our equation will be negative 4 times 5. And if we know the rule for multiplying integers, negative times a positive will give us negative because they're different signs. So our negative 4 times positive 5 will give us negative 20. And if you add them all, that is negative 20 altogether. However, that is not going to be our final answer because this problem is asking us about distance. And we know that distance is always positive. It can never be negative. It's impossible to travel negative 20 feet. And again, because of absolute value, distance is always positive. So for our final answer, we should say that the ball traveled total of 20 feet over 5 seconds. It has to be positive 20 because again, distance can never be negative. All right? Again, if you have any questions, please make sure you ask or write it down, remember it so that you can ask me next time, okay? So our next problem number 4, this will be the last one. It says, if the temperature drops 3 degrees per hour, then how many hours will it take to drop 12 degrees? So let's identify the integers. First, it says that the temperature drops 3 degrees per hour. Because it says the word drop, and it's a dropping speed, the first integer has to be negative, and it's negative 3. Now the second part, it says, how many hours will it take to drop 12 degrees? So it's drop, the word drop means negative again, so our second integer is also negative, which is negative 12. So if we think about how this works, we're looking at a thermometer again. So we're going to draw a thermometer, which will look like a vertical number line. And the temperature is dropping 3 degrees every hour. So I'm going to start at 0 degree, and I'm going to number it down, so you can do that as well, okay? Number from 0 at the top, probably down to maybe negative 14, negative 15. So make sure you label the number line. Again, like the increments here, okay? Okay, sorry I just got a picture, but you should be drawing this on your paper, okay? So again, if we think about how it works, we're going to start at the top and we're going to be dropping 3 degrees every hour, okay? And then we're going to see how long it takes to drop 12 degrees. So let's do this. So starting at 0, we're going to drop 3. So 1, 2, 3. We're going to end at -3. We dropped 3 degrees. That's 1 hour. And then we drop 3 degrees again. 1, 2, 3. We're going to end at -6. That's another hour. Because again, we know that it's dropping 3 degrees per hour. So we're going to drop, after 1 hour, we're going to drop 3 degrees again. And that's going to be at -9. So far, 1 hour plus 1 hour plus 1 hour, that's 3 hours. And then we're going to drop 1, 2, 3 degrees again, and we are at -12. So again, we went 1, 2, 3, 4 drops of 3 degrees to get to -12 degrees. So after 4 hours, we are at -12 degrees. So this one is kind of tricky. It's actually a division question, and you could also think of it this way, where you're starting at 0 and you keep subtracting 3. So the temperature dropped 3 degrees 4 times until -12 degrees. And again, we can say it as we're starting at 0, subtracting 3, subtracting 3, subtracting 3, and we subtracted 3. We dropped 4 times. And that got us to -12, right? Now, this is actually a division problem. Again, there are 4 groups of 3, or it's a repeated subtraction. So we're going to use division for this problem. For a division equation, we could say -12 divided by -3, or we could also say -12 over -3. There are 2 ways to write it because division, again, is same as fraction. So -12 divided by -3, we're dividing same signs, so it's going to be positive, and 12 divided by 3 is 4. It's +4. And we did figure out from the picture that together this took us 4 hours. So for our final answer, we should say that it will take 4 hours for the temperature to drop 12 degrees. And that's all for this lesson. I will see you next time. Thank you.